In this video, we're going to discuss about surds. Now, what is a surd? A surd is a number that cannot be simplified to remove a square root or a cube root. Some examples of surds that we have, you have the square root of 2, the square root of 3, also the square root of 3 plus 4, the square root of 11. Now, you cannot simplify this one further. For example, the square root of 2 will give us a number like, when we do the square root of 2, we're getting 1.4142135562, and the number keeps on going. So you cannot simplify it further. However, there are certain rules that we use to manipulate surds. Let's look at some of them. Rule number 1 is if you have the square root of, let me say, a and b, you can write this one as like this: a multiplied by root b. So this is one of the examples how you manipulate surds. Then the second rule that we can talk about, if you have a square root of, let me say, this is a, then you have b here. So how do you manipulate that? You just say the square root of a over the square root of b. Now there's also another rule that I must mention, because this one is also very, very important. If you have the square root of a, it's multiplying by the square root of a, you're going to get, let me say, the square root of a, this will be squared because there are two. Now the square and the root will cancel, so you just remain with a. This is one of the important rules that you must remember as you'll be, manipulating these surds. Let's take for an example. Okay, let me say you're given to find or to manipulate this one. Okay, to evaluate the square root of 28. How are you going to do that? You're going to look for two numbers that you can multiply to give you 28. We can multiply 4 multiplied by 7. Then by the second rule that we showed, you do the square root of 4 multiplied by the square root of 7. Then now the square root of 4 is just 2 multiplied by the square root of 7. Now you are done for this one. However, I must make mention that the square root of 4, we usually say it is equals to positive or minus 2. But however, the negative part doesn't really apply when it comes to surds. So with surds, the square root of 4 is not equals to positive or minus 2. So the square root of 4 for surds is just positive 2. We are just getting positive numbers. Okay, let's have another example. What if you are told to find the square root of 72, this divided by 2? So it's the same procedure. You can simplify on top. You look for two numbers that you can multiply to give you 72. So we can divide 72 divided by 2, that is giving us 36. So 36 as a root, so 36 times 2 divided by 2. Now the square root of 36, we know that it's just 6. Then the root 2 remains, divided by 2. Now we know that 2 and 6 are 6 is divisible by 2. You can divide 2 into 6. So 2 divided by 6, or 6 divided by 2, you're getting 3. So our answer will be 3 root 2. So we are done for this one. Let's try another one. Let's say you have 5 root 6 minus 2 root 24 plus, let me say, the square root of 294. Now how are you going to simplify this? Okay, so we're still looking for potentials, which ones we can manipulate. So these ones will just remain. Which two numbers can we multiply to give us 24? We can multiply 4 and 6. So 4 multiplied by 6 plus, then which two numbers can we multiply to give us 294? So you start dividing that number by 2, and you'll be progressing until you find a number that has a potential root. So when you multiply 49 multiplied by 6 will give you 294. So now how do we simplify this? So continue, say 5 root 6 minus 2. Now the square root of 4 multiplied by 6, you know that the square root of 4 is 2, right? So you say this is 2, then you remain with root 6 plus, then the square root of 49 is 7, you remain with root 6. Okay, we simplify again, we say okay, we can simplify further actually. So you have 5 root 6 minus 2 multiplied by 2 will give us 4, so this will be 4 root 6 plus 7 root 6. Now you remember that if you've got numbers like, let me say you've got 5x, you know, 5x plus 4x plus 7x, or 7x actually, they'll give you probably, let's say 0. So because all of them have got x, so all these are like terms. So even in our case, that's what we're just talking about here. So our answer in this case, we're just going to, you know, do the math. 5 minus 4, that is 1. 1 plus 7, that is 8. So we have 7. Then the root is common, which is root 6. So that is our answer for this problem. Let's try another example. What if you have you know, 2 root 7? Let me put this one in brackets. Okay, this multiplying by 3 root 7. What are you going to do? So this 2 will multiply with that 3, and this 7 also multiply with that 7. So let's do the math. Okay, so 2 multiplied by 3, okay, that will give us 2 multiplied by 3, that is like 6. Then root 7 multiplied by root 7, remember from our rule we said if you have root a multiplied by root a, it just gives you, you know, root a, this is squared. Now the square root, the squared and the square root will cancel, you just remain with a. So even in our case, this root 7 multiplied by that root 7, it gives us 7. So this is 6 multiplied by 7. So 6 multiplied by 7, that is 42. Okay, so that's the answer that we get. Let's try another example. We have 2 root 3 minus let me say root 5. This is multiplying by 2 root 3 plus 2, let me say root 5. Okay, how do we simplify this? So it's the same principle. We're going to use, you know, the principles of Surds. So this is 2 root 3. We can't simplify it any further. Minus, you know, root 5. Okay, so what are we going to do in this case? What this means is that let me also put this one in brackets. So what this means is that the 2 root 2 will multiply by everything that is in the brackets. Then also the negative root 5 will multiply by everything that is in the brackets. So that's what we are going to do. So let me do just that. Okay, we're saying this is closed. So let me just do that. So you have your 2 root 2 or your 2 root 3 multiplying by everything that is in the brackets here. So it's multiplying by 2 root 3 plus 2 root 5. Then on the other hand, your negative root 5, this one is multiplying by 2 by everything that is in the brackets on the other side, plus 2 root 5. Now how are we going to solve this? It's the same principles. This 2 multiplied by this 2, the 3 multiplied by the root 3 multiplied by the root 3. So let's proceed. So we know that 2 multiplied by 2, that will give us 4. Then this root 3 multiplied by that root 3, it will just give us let me say it will just give us 3, plus this 2 root 3 multiplied by 2 root 5. 2 multiplied by 2, it will just give us 4. So we say 4. Now we've got root 3 multiplied by root 5. Root 3 multiplied by root 5 to give us 15, right? Yeah, to give us root 15. Then let's come to the other side. We've got negative 5, negative root 5 multiplied by 2 root 3. So it will just be negative 2. Then since we are saying negative 5 multiplied by negative root 5 multiplied by root 3, it will give us 15 as well. So root 15 here. Then negative root 5 multiplied by 2 root 5. What are we going to get? So we're going to get negative 2. Root 5 and root 5, they will cancel, you just remain with 5. So now let's simplify this. 4 multiplied by 3, that is the 12, plus we have 4 root 15 minus 2 root 15 negative 2 multiplied by 5, that is 10. Then we put the like terms together. So we've got 12 minus 10. What is 12 minus 10? That is 12 minus 10, that is 2. Okay, yeah, 12 minus 10, that is 2. That is 2. Then we've got positive 4 minus positive 4 root 15 minus 2 root 15. So you're just going to get 2 root 15. So you are done for this one. Now let's talk about something very vital for Surds. Okay, something very vital, what we call rationalizing Surds. Now how do you rationalize the Surds? What are we talking about? Rationalization of Surds. So okay, you want to rationalize Surds. Now there are rules on how you rationalize Surds. The first rule that we are going to talk about is if you have a form 1 over the square root of the square root of a, what are you going to do? In this case, you are going to multiply by root a on both sides because you want to remove the root down. So you get an answer where you multiply the numerator by the numerator, you're going to get root a. Then we said root a multiplied by root a, that just gives us a. You've removed the root that was down. There was a root down here, but you've removed it. And that's what we call a rationalization. Then another principle that you need to remember is the principle of the conjugate. Now if you have let me say 1 over, let me say the square root of a minus the square root of b. So you are going to multiply by the conjugate on both sides, or the opposite of root a, and the opposite of root a minus root b in this case is root a plus root b. So you are going to multiply this on both sides, both on the denominator and the numerator. So now how do you do that? So you multiply the numerator as 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus root b. So you're just going to get root 1 multiplied by root a plus a plus b. Then down here you see that this is the difference of two squares. Remember the difference of two squares, you know, in your math, when you have this is the difference of you know, of two squares. So that's what is happening here. So we're just going to get okay, so we usually always get the one that has a negative. So we'll get yes, we'll say the square root of a, this is b squared, minus the square root of b, even this one is squared. So what are you going to do now? Okay, let's just erase here. What are you going to do? What are you going to do? Okay, so what are you going to do? You have on the numerator, a plus b will remain, or a plus root b actually will remain. This is root b. Okay, this is dividing by, you know, the square root of a squared is just a, minus the square root of just of b squared is just b. So by doing that, you've simplified the surd. By doing that, you've simplified the surd in terms of you've rationalized the surd. Now let's look at some of the examples that you can solve here. Let's say you have let me say you have 3. This 3 divided by, let me say, root 5 plus root 2. So now how do you solve this one? So it's the same issue. You have to multiply by its conjugate. So what are you going to do? Let me say you are going to multiply this by its conjugate, and the conjugate in this case, it will be, you know, root 5 minus root 2. This is the denominator. Then on the numerator, the same thing, minus root 2. So on top, 3, the numerator 3 is multiplying by 5, or this one here. So you say 3 multiplied by, you know, root 5 minus 2 minus root 2. Then you come down, like we say, it's a difference of two squares. You get the one that has a negative. Always get the one that has a negative. So what are you going to do? You do, you know, root 5, this is squared, minus, you know, root 2, even this one is squared. So okay, so we proceed. Okay, this is multiplying by that. Okay, so what do? We multiply now. So okay, let's first solve down. So the square root, let me say this is the square root of 5 minus root 2. Okay, we come down here, root 5 squared, that will just give you 5. Root 2 squared, it will give you 2. So you have an answer like on the, you know, on the numerator, this remains root 5 minus root 2. Okay, this divided by 5 minus 2, that is 3. Your 3 and your 3 can divide. So your final answer will be the square root of 5 minus root 2. That will be your final answer. Now let's solve another one. Let's say you have 1 plus the square root of 2. Now how do you solve this? 1 minus root 2. Okay, it's the same principle. You're going to multiply by the conjugate or the denominator on both sides. So that is 1 plus the square root of 2. Also on the numerator, 1 plus the square root of 2. So this is multiplying by this. This is multiplying by that. So let's start. So what this means is that your 1 is going to multiply by everything that is here. So let's start. 1 multiplied by everything is just be the same thing, 1 plus the root 2. Okay, then plus 2 this 2 multiplied by everything that is in the brackets, so you have root 2. Okay, plus root 2 multiplying by root 2, we said that will just give you 2. This is dividing by, we say you always get the one that has a minus, so this is 1, this is squared, minus square root of 2, this is also squared. So what are you going to do? You say you on top you can simplify. You've got 1 plus 2, that is 3. Then you've got root 2 plus root 2, that is root 2 plus root 2. Okay, you've got plus root 2 plus root 2 over 1 squared, that is 1. The square root of 2 multiplied, the square root of 2 squared, this square and this square will cancel, we just remain with 2. Then what are you going to do? Okay, we've got 3, plus you've got your 2 root 2, root 2 plus root 2, that is 2 root 2. This is dividing by 1 minus 2, that is 1 minus 2. 1 minus 2, that is negative 1. Okay, so this is negative 1. Now you're going to divide by negative 1 on top, so you have negative 3 minus 2 root 2. Okay, so this is our answer. So this was a short video about rationalizing. Then in the next session we're going to talk about some practice questions, more practice questions on these principles. Thank you.